On behalf of the Unitil team, I'm proud to introduce my amazing fellow, Zijing Wang. Zijing is a recent graduate of Northwestern University in Illinois, where she got a Master's of Science in Energy and Sustainability. Zijing really brought passion and a keen sense for data research and literature review. She sifted through a lot of data and literature that was out there, and she really came out with some amazing gems that are very useful. So much that our engineering department wants, the draft report now, so they can start looking at it. It seemed effortless, all of her work, but I'm sure it really wasn't. She's so organized and has great project management skills as well. It's been a real pleasure getting to know her and having her here at Unitil. So with that, Zijing, over to you.
Hey, thanks, Sarah. So this summer has been an incredible journey for me as I step into the project of climate change scenario risk assessment. And in this presentation, I'll provide a high-level introduction of the project, some of my results, future implementations, and also my personal reflections. So if you can go to the next slide, Jen. Okay, thank you. So I've been focusing on something we all depend on every day, the electricity and our electric infrastructure. It is something that we often taken for granted, but it's also old and aging. So with 70% of the power transformers and the transmission lines are over 30 years old. The grid was built for a climate that no longer exists. And with more and more extreme weather happening, we are seeing more and more outages, and that lead to a significant financial losses for utilities. So that's why we need to shift from reacting to those challenges to proactively planning for climate resilience. So under the urgent need, the first critical step is to understanding the risks, and that lead to a proper risk assessment. Building some of the credible work done last year on the sea level rise. This year, I focused on another main physical risk in the Northeast region, which is so I explored the temperature-related projection across various climate scenarios, and then evaluated how those temperature changes might affect Unitil's energy infrastructure and funding the most at-risk assets so that allow for future implementation accordingly. So next slide, please. Here are some of my results, focusing something critical, the transformers, which are the top priority infrastructure under temperature projections across different SSP scenarios. So what those means was by the end of the century, every individual transformer takes roughly 2.5 hours to be derated every day to prevent the overheating in the face of rising temperature due to climate change. So my approach began with some general research and conversation with engineering and operational teams. We identified 6 key components, which you can see in the graph here. So if something is in the upper left, means riskier for that components. Then came to the data analysis. I adapt a regression model from various studies, which helped me to quantify those risks, how the transformer might be affected over time, and showing the bar graph in the middle. So the next stage going to be combine those information with the GIS geographic data, so allow us to quantify the total risk, and then you can plan for how to respond to those in the future. And to the next slide. So as I mentioned earlier, building climate resilience is more than just one-time effort. It involves long-term evaluation, careful planning, and adaptive to those changes. So this project is also an ongoing one. After identifying the priority components, next steps going to be working and developing detailed models and calculations tailored to the specific assumptions based on Unitil situation, and have some strategy options going beyond, such as decentralizing generation, battery storage, microgrid, etc. And in terms of my personal learning through this journey, I've gained profound understanding of the complexity, the nature of the climate risks, and also in the energy systems. So this project to me is more than, it's not just like crunching numbers or forecasting scenarios. It's more of a complex process of understanding, setting priorities and collaborations, and also taking sustainability initiative step by step. So in the last, I like to thanks to my mentors for their guidance, and also my fellow fellows for their collaborations, and UNH for this incredible opportunity. The biggest takeaway here for me is that climate change is undoubtedly a challenge, a threat to the aging electric grid and to area sectors, but it doesn't have to be a losing battle. With informed, proactive step, we can turn this challenge, this risk into an opportunity. It's about being resilient, forward-thinking, and most importantly, taking action in the future. Thank you.
Great work. Something we talked about a lot was balancing all the different interests. So Unitil has interests and their customers have interests and different folks, and the environment has different interests. So how do we balance all these interests in a way that is sustainable for all, in your perspective?
So initially when I was doing doing this project, I always feel like the risk, you have to quantify that, but at the end of this project, I feel like risk always go with the opportunities. For the utility itself, facing all those their critical infrastructures under the rising temperature, but if you can do a proactive climate resilient plan, you can actually save money because of that. And for the customers, probably do some of the residential solars, as some of fellow mentioned earlier, just like a collaborative way that we can all take steps and making all those risks into opportunities facing climate change. That's my understanding.
Great work.